Hello guys, my name is Krita. I am a student of Basic Chemistry Honor first year in Padine Nikiram Sharma Government College. Today I made a video for the presentation of organic chemistry. My topic is hyperconjugation. Our topic is hyperconjugation. The definition of a hyperconjugation is the process which takes place when a sp2 hybridized carbon atom is attached to that sp3 hybridized carbon atom having at least one hydrogen atom is called hyperconjugation. Example of a hyperconjugation is primary carbocation. Let's see. This is sp2 hybridized carbon atom and it is attached to the sp3 hybridized carbon atom. And there is a next hybrid conjugated structure is and next example is primary free radical. This is sp2 hybridized carbon atom and this is attached to the sp3 hybridized carbon atom. So it is in a hyperconjugation state. And there is a next hyperconjugated structure is half-headed arrow. During the process of the unhybridized orbital of the sp2 hybridized carbon atom overlaps with the filled orbital of the sp3 hybridized carbon atom. The hyperconjugation is also called no-bond rejuvenation. Called no-bond resonance. Because in the different hyperconjugated structures there is one of the hydrogen atom which forms no bond with carbon atom. You have to see it in the above examples. The hyperconjugation is also called Becker-Nathan effect. Because this scientist gives this theory. It's given by them. It is to be noted that more the number of hyperconjugate structures, more will be the stability. The number of hyperconjugate structures formed will depends upon the number of hydrogen atom attached to the sp2 hybridized carbon atom. sp2 hybridized carbon atom. Applications of hyperconjugation. This effect is used to explain the stability of different carbocation. Reason is we note that more the dispersal of charge, more will be the stability. We have to see in examples. Primary carbocation. Structure of primary carbocation is this is sp2 hybridized carbon atom and this is sp3 hybridized carbon atom. Another hyperconjugated structure is this is hydrogen atom which is no bond in resonance. Next structure is this carbon is no bond resonance. And there is a next third structure is in the structure this is the hydrogen atom which is no bond with carbon atom. In a primary carbocation, 3 hyperconjugated structures are present. Second is secondary carbocation. The structure of secondary carbocation is this is sp2 hybridized carbon atom attached to the sp3 hybridized carbon atom and this is also the sp3 hybridized carbon atom. The next structure is in the secondary carbocation 3 plus 3 equal to 6 hyperconjugated structures are present. In the tertiary carbocation, this is sp2 hybridized carbon atom attached to the sp3 hybridized carbon atom There another hyperconjugated structure is and hyperconjugated structure is this. You seen another hyperconjugated structures like this. First carbocation. There is P plus equal to 9. 9 hyperconjugated structures are present. On moving primary carbocation to secondary carbocation and tertiary carbocation, the number of hyperconjugated structure increases. And the extent of dispersion of positive charge also increases. So the stability of carbocations is also increases. Then the stability order is tertiary carbocation is more stable than secondary carbocation, and the secondary carbocation is also more stable than primary carbocation. And the next application of hyperconjugation is this effect is used to explain the stability of different free radicals. Reason is same as carbocation. We know that the more the dispersal of charge, more will be the stability. And the first example of free radical is primary free radical. And the structure of primary free radical is and there is another hyperconjugated structure is in the primary free radical there are 3 hyperconjugated structures are present. In the secondary free radical, structure of secondary free radical is the structure of secondary free radical is and there are another hyperconjugated structure represents and there are 6 hyperconjugated structures are present. In the tertiary free radicals, the structure of tertiary free radical is There is another hyperconjugated structure represents in the tertiary free radical. 3 plus 3 is equal to 9 hyperconjugated structures are present. On moving from primary free radical to secondary free radical, and the tertiary free radical, the number of hyperconjugated structures are increases. And thus the extent of dispersal of odd electrons are also increases. So the stability of free radicals increases, and the stability order is tertiary free radicals is more stable than secondary free radical, and the secondary free radical is more stable than primary free radical.